Tonight we turn to one of ancient Egypt's most puzzling sites, the Serapeum of Saqqara. Engineer and researcher Chris Dunn has spent years studying the enormous granite sarcophagi buried beneath the desert, questioning how they were quarried, transported, shaped, and finished with such apparent precision. In this episode, we look at Dunn's Serapeum research, the engineering questions surrounding these massive stone boxes, and why they continue to fuel debate over the capabilities of ancient Egyptian technology. Chris, have you come to any conclusions about the precision of these granite boxes in the Serapeum and how they got them down there? What are they? Some 80 tons or something in weight.
Yes, they probably would have weighed that or more when they were brought down. And the other incredible thing is that they were finished underground, which is
Wow.
because you find a rough box uh, actually in situ there in one of the passageways. It has no finish on it whatsoever, and also an unfinished lid. Um, but the lids weigh about 20 tons just themselves. So if you take the whole assembly, you've got about 80 tons of granite there. But just the fact that they brought them understand speaks volumes to me, because and also reinforces the idea that they needed to achieve that precision, they needed it for a reason. Because
Yeah.
if you had finished that box in a different environment, say above ground, in a different temperature, with the sun shining down or whatever, and then you bring it down into the cool confines of these rock tunnels, then the temperature differential would cause some warping of the material, and then you would lose that extreme precision. And that itself, actually, as I said, it reinforces the intention of the builders to achieve something very precise. Now, you asked the question, what do you think that precision was for?
Mm.
Um, well, I would dismiss the idea that they crafted these boxes so that they could put the carcass of a bull in there.
Yeah.
Uh, and I have to consider a more technological purpose. And of course, with my previous research on the Great Pyramid, and the conclusion that I made that the ancient scientists, engineers were working with resonance and harmonics. Um, they had I have to think that their technology was based on sound and harmony and resonance, and that harmony and resonance and frequencies were in tune with nature, with the earth, and with the universe. So these boxes, I think, from my perspective, were resonant cavities. Now, what the objective was, and in fact, as far as what they were achieving, that's a bit of a mystery. You can speculate that they were a part of the entire system. Exactly the same kind of accuracy uh, in the Khafre's pyramid as you find in the Serapeum. So, well, within any enclosed space where you have flat walls, you'll have reflections. Uh, but as far as the tunnels themselves, that I didn't pick up that there was any intention for them to be anything but uh, access tunnels. But it seems to me that that whole area, the the Saqqara area, it's almost like it's riddled with tunnels, and the bedrock is like I don't know, it's like a soundboard. I mean, sound travels
Oh.
extremely well through that area. There are areas that you can go to near the Saqqara pyramid
Mm.
where sound will be traveling through the ground. Even the throb of the buses in the parking lot. You could be hundreds of feet away. You can go into areas where you will actually hear that thrum. I mean, that that uh, that bit of research was incredible for me, um, because I was able to demonstrate and show very clearly that they not only do you have the shape of the tool defined, you have the orientation of the tool, and you also have the marks that the tool left.
Mm-hmm.
And this is a concave block that shows that they were using a saw that was about 37 feet in diameter.
Wow.
And I know it sounds astounding, doesn't
Meg-
it? The mega saw. I mean,
But
it's
it is.
bigger than the channel borer, that went through the. Was I think that was about 27 feet in diameter.
Wow.
So but it kind of puzzled me at the start because I was looking at and examining flat surfaces all over the place,
Yeah.
and I was at Abu Rawash, which is about 5 miles away from Giza. It's up on a hillside,
Yeah.
and I climbed to the top of the pyramid, and I'd walked over to one of the corners, and I noticed that there was this shiny black piece of granite down near the base, and I thought, maybe something I can put my straight edge on. So I walked down and I walked up to it and I put my straight edge on it and I go, wow, that's not flat. That's got a curve to it. And so at that time I was like, that's very interesting. I'm going to have to examine this a little more. I was actually with your friend David Childress at the time, our friend David Childress.
Yeah.
And he had hooked up with me after I finished the tour with John Anthony West, and we did some filming at that time. But anyway, I that was it for that particular trip. I'm looking at it. I'm looking at this curve on the surface, and then I see where the piece had broken off, and right at the break point, there are these curves too. Um, and so it indicated that yeah, they had used a saw. But the question in my mind was, well, what kind of saw was it? How big a diameter was it? How did they fixture it? All of these questions I walked away with in my head unanswered. And so then in 2006, that was of course the place I headed towards. I needed to go there and check it out further, which I did. And this time though, with my camera, I took a very good tripod or camera stand, and and so that I would be able to take the photographs carefully, and make sure that the camera was still. I also had a zoom macro lens so that I could zoom in on the surface and take a photograph that would reveal more about the surface of the granite. Um, so my intention then was to take photographs along the X plane, um, or the Y plane, and the X and the Z plane. It just involved actually the analysis just involved the Z plane and the Y plane. If you consider the Z plane to be the center of a cylinder, um, and then the Y plane, the vertical line going through that center. I took photographs along the Z and the Y plane, and then looking at those photographs, we see that there are these arcs where the saw actually stopped, and by measuring the geometry of those arcs, I was able to determine the dimension and the angle of the saw. Um, what when I saw that it was about over 37 feet in diameter, my jaw dropped. I was like, nobody's going to believe this, you know. And in fact, many people don't. But I mean, the devil's in the details, and uh, anybody can go out there and take their own photographs and do their own analysis. But that piece needs to be in a metrology shop, or needs to be in a lab and examined in great detail, because it is a smoking gun. If you look at very closely at the surface, you'll see that the feed lines are quite regular and pronounced. And so this is not an object that was created with a copper chisel or a bouncing ball. Uh, totally impossible. But then, thinking about that size saw, I was like, well, how did they fixture it? Because what you have is a saw. It's 27 feet and 37 feet in diameter. And, when you saw something with something like that, you'd be moving the piece rather than the saw, and they'd have to get it up on the axis. So you have to be at the center of the saw. And then I was like, and then I'm looking over to another area, and there's a very interesting feature there, and it's this deep pit that it was dug. Probably about 20, 30 feet away from where that piece was found, where I found that piece. And normally those pits have been described as boat pits, where the pharaoh had his method, his boat, the solar boats were buried along with the pharaoh as a symbolic gesture for his travels into the afterlife. And there's several on the Giza Plateau, and they've always interested me on the Giza Plateau. But at that moment, it all came together for me, and it's like, this really makes sense now, because it kind of brings the building of the pyramids more into something that will be more achievable in our world, because we've always puzzled about how we would build a great pyramid. Normally we come up short. Yes,
Yeah.
and it kind of said, wow, okay, this makes sense. You bring your blocks to the site, they're quarried, you bring them to the site, you cut them to size, and then you install them in the pyramid. And they were doing it very efficiently. And it was on an industrial scale, a mega industrial scale. Well, I don't know if anybody else would want to take credit for it, but no, that's my idea. Well, I mean, obviously, I think Egyptologists are going to stick with their story. I mean, that's firmly embedded in their training. Well, how troublesome engineers are. The same happened in Egypt, when Zahi Hawass discovered the workers' village, and Mark Lehner was mapping it out and writing papers on it. There was an Egyptian architect that contacted me, and he went to a lecture by Mark Lehner in Cairo at the American Research Institute in Cairo, and he asked some awkward questions. And one of them was, did you engage any construction engineers or architects in your analysis of this village before you came to your conclusions? And that was very awkward. He asked another question, and that was, does this look like the work that the ancient Egyptians were capable of doing? It doesn't seem to be, it didn't seem to correspond with their skills. Oh, that was awkward. Those are the kind of questions that Egyptologists should be asking themselves, because they're digging around middens and finding, crude structures that are put together like crazy paving. It's just like the dry stone walls. But they didn't engage anybody and ask those questions, and that seems to me to be a real a fault or a blind spot. But I'm not sure that you can overturn the particular mindset that you have in universities, um, because um, I think our attempts at trying to rewrite history, we are looked at as just amateurs in terms of being, rewriting history. And a lot of attempts in the last 20 years to explain Egypt or explain other cultures in a different way have not, yeah, deaf ears on one hand, and then a lot of kind of really out there ideas that are not founded on credible evidence. And so, when you're kind of mixed in with that group, the whole group is kind of rejected or dismissed. And I've got to be honest, I mean, my ideas obviously are extremely controversial, and I was expecting them to be dismissed by conventional academics or Egyptologists, and I wasn't surprised. I mean, that just totally overturns the paradigm, and it creates quite a intellectual challenge and a philosophical seismic shock, really, because let's face it, we are raised to believe that we are at the pinnacle of technological progress and that, life continues. We go happily forward into the future. But what this reveals is that civilizations are mortal and, they can be wiped out in an instant. And to argue that did not happen in this case, I think is we're doing a disservice to people's intellect. It's like, oh, you can't handle the truth. I think I am comfortably ignored. I don't know that I don't know that they even give me any concern. There are a few people who, yeah, I don't, but I don't spend any time worrying about those guys.
Sure.
I'm quite comfortable doing my thing and documenting my observations. I don't sit around worrying about what this person's going to think or what that person's going to think. Well, just show me the facts, and we'll talk about it. That was something that really popped out at me after I went to Abu Rawash, because then I started looking very carefully for more examples of the use of those kind of saws, particularly when you find those pits on the Giza Plateau too. And the finest example is actually near the basalt pavement, where you see the marks left by these mega machines that were cutting basalt, very hard stone, igneous rock, and cutting it very efficiently. And the tool marks are there, the striations are there, the geometry is there. It's an engineer's playground. It's like the Mecca for engineers. Go to Egypt, go on a pilgrimage, be humble. I haven't done the measure of the casing stones. There are very few of them left. There's a couple on the north side. But Petrie had measured them. He reported they were within 10,000ths of an inch over 75 square inches. And so, and then they fitted together to line to line with a maximum of 20,000ths of an inch gap. That, to me, is not as precise as what you find on the inside of the Great Pyramid. So if you go on the inside and head down to the Queen's Chamber and look at the way the blocks that form the Queen's Chamber are fitted together, you'll find the kind of precision that you're talking about in terms of not being able to slip a piece of paper between joints, and also in the King's Chamber and the Grand Gallery. Throughout all the chambers on the inside of the Great Pyramid, those that were constructed, they were using extreme precision. I mean, very deep roofs, about less than 1/8 of an inch thick or wide, and 10 times as deep. So the aspect ratio is fairly significant. And you have to ask, how were they doing that? I mean, and then the tool marks on the bottom of the sunken reliefs that you can determine there. It's all over the place, and once you start to look for it, it's not like looking for faces in the clouds, or and it's it's definitely it's the hard facts, and and it's the same in Peru and Bolivia. I mean, you have the similar precision, not quite to the extent that you find in Egypt, but it's definitely they were definitely doing something. I think the jagged design is very interesting too. I don't know. I mean, I just the the task of putting the thing together, fitting all the blocks together.
I mean,
I don't know. I've thought long and hard about that. I mean, normally when somebody imagines how they fitted it together, they would have them lift one piece on the other and find out where they need to remove material, take it up, remove that material, put it back, so on and so forth, until they got a good fit. It does seem like, wow, it just actually lifting some of those blocks and accomplishing that. A kind of agrarian civilization that was not technologically advanced. How would you even come up with such a concept of doing that, or think that it was within your reach to do that? It's quite amazing. But then, the other thing, there's a lot of mystery in Peru and Bolivia, that's for sure. And how they accomplished what they did is still a mystery. But one of the things that occurred to me the last time I was there was that they actually built those walls horizontally before they put them vertically, or they fitted them horizontally before they put them together. And they were able to, hold the stones in position and have and be able to roll them. I mean, you find all these balls, and they found a lot of balls under the structures in the Coricancha, and so their technique for moving these blocks around, maybe they were able to fixture this on a piece of wood or something, or whatever, or in some way be able to move those blocks horizontally, and then just
the ground.
And then, you could bring a block in proximity with the other, and then use a scribe, and then use a spacer to actually determine whether you have the
allowed or not.
fit. I think more for seismic purposes than anything. It seems to me that they were putting balls under their structures so that when the ground moved, the structure didn't move the same way as the ground was. But that's just. But how did the ancient people do things? You can't always immediately jump to the conclusion that they were using anti-gravity or machines. And the Sacsayhuaman is a prime example of a structure that looks like, well, there's no way that it doesn't have the precision of machine work, or it is not that you don't have identical geometry and surfaces that you can measure and say, oh yeah, okay, they were doing this over and over and over again, and so they had some kind of design that they were working with. Yeah. I think we know as we get older that our consciousness is going to fall from grace. It's called aging. Well, I went there originally in 2005, and and what I had taken some tools with me, inspection instruments, and we went to La Paz. I found that I couldn't use the full range of instruments that I had, so we went to La Paz, and we were going to spend one night in Tiwanaku, and the um, because of what I was able to see in Peru, I wasn't really anticipating needing the precise instruments that I brought along, and so I left them at the hotel in La Paz, and then we went out to Tiwanaku. So we got to Tiwanaku and went to Pumapunku, and then I walked on site, and the first thing I noticed is this block sitting in the middle, uh, with a series of holes drilled into a groove. I went to that block, and I looked at it closely. I felt the surface. It seemed to be extremely flat, but I had no means to tell me how flat it was. So I got the driver, paid him money, of course, and I just I could not leave this place without checking it further or a little more closely. So I had him drive me back to La Paz, where I got my suitcase that had all my tools in it, and then we drove back to Tiwanaku. And the next day, I was able to, get my straight edge on it, my square, um, and also calipers to measure the distance between the holes and look at some other stuff. And on another trip, I had a surface gauge with an indicator, and I was able to check some surfaces that appear to be extremely flat. I say indicator, that's the American term. In England, we called it a clock. Um, I think you know what that is, yeah? It's
Mm-hmm.
it's a gauge for actually measuring the displacement um, of irregularities or the condition of a surface. So you run it across a surface, you'd be able to check to see what the tolerance of the surface is. And these flat surfaces were within half a thousandths of an inch, which was incredible.
That's
Yeah.
I went back in 2011 and did the same thing, and I had some observers who verified and actually did the same test. And but I was also very interested in the H blocks, and so I did some measurements of the H blocks, because what I wanted to know was how consistent the cavities were in the H blocks, and whether they showed some regularity or replication of a particular methodology or geometric measurements, precision. And what I found with those was that these cavities were not parallel. The walls were not parallel with each other, and they were actually dovetailed, which kind of shocked me. It was interesting
wow.
because all the illustrations I'd seen on these blocks showed them the surfaces to be parallel.
Mhm.
And so I wanted to find out, how precise they were. The blocks that I measured, the cavities that I measured, varied about 300 thousandths of an inch, almost half an inch.
Wow.
So obviously, you can't argue that they were making them all the same, identical. But the similar features, though, were very interesting. The surfaces were extremely flat. The corners, extremely sharp, with a relief cut in the corner of them. But it was the geometry of these cavities that caught my attention, because they were dovetailed, and so when we consider what we use dovetails for, Uh, we use them in cabinet making. We use them, they're very effective assembly feature when you're trying to assemble something to hold something in place. And so, the next question in my mind was, well, what were they doing with these dovetails? What was going into these cavities? What was being held in place? And the idea came to me around 3 o'clock in the morning, when most of my ideas actually pop into my brain. Was that they were actually using those blocks as hinge blocks. They were installed in the doorways and the walls, and then into those cavities had uh, they had insert through which they put a hinge. And so I created one of those, an example of one of those, and I did a demo for Ancient Aliens and showed how that would have functioned. It did explain, and it worked very well. I mean, it works, it whether that was the precise reason for them. I don't know. It's all theory, obviously, but but it does kind of explain the reason why there are only a few of them, rather than a sufficient number to build a whole wall. Because a lot of the artist impressions that I've seen show these blocks being assembled into actually locking together and being assembled to make a whole wall. And being more of an architectural feature rather than a functional feature. And so, that seemed to explain that we don't have more of those. And also the fact that from one block to the other, you don't have regularity in the dimensions. And and I didn't see any feature that where in the area that you could say, okay, this interlocks with this interlocks with this. But anyway, so that was a very interesting trip, and I need to do more study down there too, and I plan on doing that in the future.
Very people orientated, Gary. I like what he does. I like talking to him as well. Yeah. It's quite a big tour that Gary had that time as well. It's quite successful, he was telling me. So
It was a huge success, and it wasn't just the size of the group, but the character and oh yeah, yeah. And of course, we had a passionate discussion at one point, and it was like he was going at it, and I was going at it.
Mhm.
And I think the rest of the group thought we may be mad at each other, but that wasn't true. That's we both have strong ideas and
Mhm.
express them,
He did.
uh, and there's no animosity, none at all. So it was a wonderful trip. I enjoyed it.
Sure.
Well, it was one of those things that happened, and it's kind of like, um, what is retirement, and I don't know. Um, yeah, I had planned to do a lot of stuff after I retired from the old company. Uh, writing more books, doing more traveling. I don't have any plans for the rest of the year, except to continue working, and wherever that takes me. Um, I do have a project that I'm working on that I'm very excited about. Um, I don't know where that's going to lead, but just the prospects of success are very exciting.
Wonderful.
And it could also tie into the ancient technology kind of area. Yeah, and so that is a kind of exciting. It's almost like I studied it. I wrote about it in the Giza power plant, and
Yeah.
then I was off doing other things. And it was always my intention to go back to it. But like everything else, you have to have some things don't happen until the time is right. So that the time was never right, and uh, and now it is. So now I'm actually going to focus on that.
Sounds fascinating.
Well, in the hyperstyle hall, there's about 24 of them, but with 4 sides. I think so, and it's hard to say how the climate will change over there, and but we always have hopes. I mean, I've had interest expressed from people who are actually on the ground in Egypt, professionals, and it's just a matter of engaging with them, finding the time and money to actually do more research there, and I think that is the answer, in my opinion. But the photographs that I did take did allow uh, a lot of good information in terms of how the columns were oriented and related to each other. Well, the way I see it, and honestly, and I've recognized this for a long time, is that I serve as more as a bell ringer. I'm more going over to the piece and I'm waving a flag or ringing a bell and saying, okay, we need to look at this a little closer. Well, William Flinders Petrie did his best in his time, and but before you start to engage high precision instruments, your mind has to be turned towards the possibility that they existed in prehistory, and that's where Egyptology they have not come that far yet. They can't. He was measuring the inside of the coffers with chains, and so that's where you have to say, yeah, he was a surveyor. He was using the tools of his trade and doing the best job he could, and so we'll add to the record now and use more precise instruments and see what they reveal. He was a brilliant man. He was had very keen observation. Exactly. And he was the son of an engineer, by the way. What does that tell you? It's a good. It is a good field to be in. That's for sure. Well, it's been a pleasure being here,